welcome to Go Math with Miss Janky. Today we are studying Module 10.1, but we're only looking at day 1 of our notes. We are going to be splitting up this lesson into 2 days, day 1 and day 2. So today our topic is modeling and writing expressions, and our essential question that we're studying today is how can you model and write algebraic expressions? And we do have 3 vocabulary words that you do need to get written down. So you can go ahead and pause the video while you get these ones written down. Algebraic expression is an expression that contains one or more variables. So remember, variables are like x, y, any letter that represents a missing number is a variable. And that brings me to my next vocabulary word, which is variable. A letter or symbol used to represent an unknown or missing number. And you can choose any letter that you want to use for your variable. And the next vocabulary word is constant. A constant is a specific number whose value does not change. And we are going to be using these 3 vocabulary words as we work through Module 10 and the rest of our Go Math book. I do have a tip for you about algebraic expressions. And that tip is that in algebraic expressions, multiplication and division are represented differently than we typically see them. So let's take a look. So instead of using the time symbol like this for multiplication, I'm not using that anymore. Instead, for multiplication, I am going to use a dot. And we've talked about this before in previous chapters, but really you're going to be seeing it today. Multiplication will be written as a dot, or there's even another way to write multiplication. So if we needed to write 3 times the variable n, we would write 3 dot n, or we could write it a shortened way, which is 3n. When you see a variable right up against the number, just like we had discussed in Module 7 when we dealt with proportions, when we see a number right up against a variable, that tells us that it is a multiplication operation. The variable is like its partner. So this is 2 ways that you can show multiplication. So for practice, I want you to do 8 times j, and you are going to write that in 2 different ways. Now let's talk about division. So division is a little bit different too. If we were going to do 3 divided by n, this time we could write that 2 ways. We could do normal division symbol, 3 divided by n. Or the more academic way that you'll be seeing this is actually in fraction form, like this, 3 over n. Okay, so when you see this fraction bar here, that is telling us that we need to do division. So add something to your notes that says fraction bar means division, something in your own words to help you remember when you see fraction, you need to think about the operation division. Okay, the next part is from your textbook. So if you are watching this video and you have a Go Math 6th grade textbook, you need to go find this chart. This chart is on page 263 of your textbook. And you have 2 options. You can go ahead and cut this chart out from your textbook. It looks like this. Or you can go ahead and write it in. I am going to go ahead and write in each one of these words. So this is a great reference chart for you because it references all of the words that you, well, most of the words that you will be seeing in our algebraic expressions problems. So if you see words like added to, plus, sum, or more than, I want you to think about the operation addition. For subtraction, you might see words like subtracted from, and that one's kind of obvious because subtracted is in the word. Our common one is minus, difference, and less than. Also, if somebody is spending money, that is subtracting money from your bank account. So let's add that. Spending money. We see that a lot in word problems. For multiplication, our standard one is times multiplied by product, and a new one that we haven't seen very often is groups of. For division, divided by, divided into, and quotient. So as we work through this lesson, we are going to be referencing this chart to help us write out algebraic expressions. First, we're going to be looking at the modeling method, and you know our textbook loves to show us modeling. So let's go over, what does this modeling method look like? Well, from our vocabulary words earlier, this entire expression, 7 plus x, is an example of an algebraic expression. So let's go ahead and label that. We have prior knowledge that x is our variable. It's our missing number. We don't know it yet. The plus sign is our operation. It tells us what to do. Operation, addition, subtraction, multiplication, or division. Unless our 7 is our constant. It's a number that's not changing. Okay, so we have our algebraic expression labeled. Let's take a look at how might we model the problem 7 plus x. Well, modeling for algebra is actually quite simple. So first we're going to look at modeling for addition. So go ahead and write addition off to the side, highlight it if you need to. And to model addition, we're actually just going to draw a bar like this. And we need to have part of it represent our x, our missing number. So I'm going to show that that is x. Now this other part here represents 7, and my operation is plus, so you're welcome to put a plus sign in between them. Now of this 7, I need to break it up into 7 squares. Whoops, I did 8 by accident, so not that one. 1, 2, 3, 4, 5, 6, 7 squares, and this will be part of my x. So I have my 7 represented here, and I have my x, my missing number, represented. 7 plus x. Notice I'm not solving, I'm just asked to draw a model. But next, let's look at modeling division. So go ahead and label this as division. And for our division problem that we're going to look at a divided by 3. And for division, we're also going to use a bar like this. And this whole bar represents a, our numerator. So I'm going to draw an A there. And inside that A, it's broken up into thirds because of our denominator. So you can label that 1, 2, 3 if it helps you. Then take one of those thirds, it doesn't matter which one, I'm just going to use this one, and that will represent A over 3. Last, let's look at subtraction. Okay, so subtraction, we're going to do the problem x minus 5. And I think subtraction is the most complicated one to model, so let's take a look. We're going to make our bar again. And I have my constant 5, so I'm going to break up my constant. 1, 2, 3, 4, 5. So that's going to represent the constant 5. This entire problem, this entire bar is representing x. So I'm doing x minus, or take away, 5, my constant. Now over here, the part that I don't know is my x minus 5. So we're just leaving that part as x minus 5. So today we've modeled addition, division, and subtraction. Next, let's take a look at writing an algebraic expression for each phrase. So you're going to see some key words within these problems. These key words are sum, quotient, product, and added to. So go back and look at that chart that you either wrote down or cut out of your textbook and decide what operation is happening here. So for the first one, we have the sum of 10 and x. So we could say 10 plus x. If you feel like you have this, go ahead and pause the video and try to do the rest on your own, then come back and check your work. The quotient of 12 and y. We could say 2 and y, 2 divided by y, or we could say 2 over y. Either way would work. The product of 15 and p. Product tells us multiplication, so we can do 15 times p. I'm using my dot for multiplication, or I can just write 15p to show multiplication. Last, I have c added to 45. Added to is telling me plus 45 plus c. C added to 45. Okay, let's look at one more example. So now this time you are given an algebraic expression and you have to write it out in words. So you get to look at that chart and decide how you would like to write it. And you can use any of those ways to show the operation. So in our first problem, we have 11x, which tells us it is 11 times x. So you can choose any language from your chart to show multiplication. You could say 11 times x, 11 multiplied by x, 10 groups of x, whatever you would like to use for your language to write down here as your phrase. So I'm going to use 11 multiplied by x. The next one, we have x over 12. So we could say for this one, x divided by 12, that would be standard. Or we could use a different one. Now we could say 12 divided into x. So notice how I kind of flipped my wording around there. So let's write both of those down. X divided by 12. Or 12 divided into x. So notice how that language changes. 8 minus y. So I could literally just say 8 minus y. But if I wanted to use some different language and mix it up, I could say something like 8 take away y. And my last one, y plus 21, or y plus 12 here. Y plus 12, I can just say y plus 12, but I want to make something more interesting. So I could say something like the sum of y and 12. Okay, this has been Go Math Module 10, Lesson 1, Day 1. Tomorrow we are going to continue with 10.1, but Day 2. And tomorrow we're going to be looking at comparing expressions using models. Thanks for watching Go Math with Ms. Janke.